Alright, gang. Unit 5, I believe, sample test review. Number 1, find the first 4 terms of each sequence. So here's the nth term. To find term number 1, you're essentially going to plug in 1 for n. That should always work, you know, when you have nth term formulas. Plug in 1 to find the first term, plug in 2 to find the second term, plug in 3 to find the third term, plug in 4 for n to find the fourth term. And so you just gotta evaluate this, crunch this out, and it looks like the first term is going to be 9, second term is going to be 14, and this is going to be 19, and that's a 20 plus 4, 24. So again, just starting real simple, plugging in 1, plugging in 2, plugging in 3, plugging in 4. And I'll say really quick that technically you can do the same thing here, even if it's recursive style, because if you plug in, oh, and by the way, this right here pretty much just means you're going to start with n equals 2, because we already have the first term, you know, a sub 1. So you can all but ignore that. Just kind of like a technicality. But anyway, so you could technically still plug in 2 for n, but that just means that this is going to become a sub 1. And when you plug in 3 here, it means that's just going to become a sub 2. And when you plug in 4, that's going to become a sub 3. So what I've been saying in class, you probably know, because you were probably in class. This entire part of the formula, a sub n minus 1, that whole thing, you can basically just think of as whatever the previous term was. So when you're finding the second term, you're going to plug in 2. And it's going to be the previous term plus 3. And in this case, it was a 2 plus 3 to be a 5. And now, when we go to find the next term, now it makes it a 5 plus 3. You're going to plug in whatever the previous term was for that part of it, and get an 8. And so, if I'm sticking with my you know, and you're going to get an 8. Okay. Actually, no, you idiot. I believe I can just make that, yeah, there we go. So, you know, when I go to find the fourth term, now it's the previous term, which is 8 plus 3 to be 11. And so those are the answers, okay? You're always utilizing whatever the previous term was in place of this entire a sub n minus 1. Number 3 is a sigma, so we're finding the sum, and we're only going from 1 to 4. And so, funny enough, 3i plus 1 actually is arithmetic in nature. So theoretically, you could have just used the arithmetic formula for a sum, but look, not only are we only going from 1 to 4, it's not like we're going from 1 to 40, but probably even more than that, you need to be ready for the fact that potentially on the test, this is not even arithmetic, nor is it geometric in nature, so you will have to be ready to just write out all of the first 4 terms where you, again, plug in 1 for the first term, plug in 2 for the second term, plug in 3 to get the third term, plug in 4, and for I, of course, plug in 4 for I to get the fourth term, to just add them up by hand, So this all just becomes a 4. All of this, 3 times 2 plus 1, just becomes a 7. 3 times 3 plus 1 is 10. 3 times 4 plus 1 is 13. And final sum, just adding all those 4 terms up by hand, is 34, I do declare. All right, because again, even though this actually is geometric, arithmetic. Even though this actually is arithmetic, you might as well just, it's only the first 4 terms, might as well just write out them all by hand and add them manually. Because again, I might not give you something that's arithmetic or geometric from 1 to 4 or 1 to 3 or whatever. Number 4. Write the first 4 terms of the arithmetic sequence. Ooh, they're telling you it's arithmetic. So it's arithmetic, and well, duh. I mean, we have a common difference, a d value of 6. Yep, totally arithmetic, right? And the first term is -3. So since it is arithmetic, and that means there's a common difference, you just keep adding the same thing every time. To get the second, third, and fourth term, why don't you just add 6? -3 plus 6 to jump to the second term. There's a 3, and then you can just add 6 again to jump to the next term, and then add 6 again, right? But I mean, you're also supposed to find the 75th term, which, I can see the convenience of, now maybe you want to bust out the formula, so you can kind of jump ahead, and the formula is just a shortcut. I mean, you're just going to end up adding 74 common differences of 6 to the first term here. So you can jump all the way to the 75th term where n equals 75, and here's the formula, and you ultimately get 441 using the proper arithmetic formula. Write a formula for the general term, nth term, of each geometric sequence. Then use the formula to find the 30th term. I've probably tried to make a big-time effort to make you understand that this is a 2-part question. I mean, look over here, part 1 answer, part 2 answer, right? But what I need here is the nth term formula, not overall, but specifically for this geometric sequence. So here's what you're going to do, as I've said in class probably half a dozen times. You're going to plug in for a sub 1, so 2. You're going to plug in for r, which is obviously what? 3, If we're going 2 and then 6 and then 18 and 54, the common ratio is obviously 3. And if there's any ever doubt, just do the second term divided by the first term, and you get 3. But what you're going to do is not plug in for n yet. And so this is going to be the first part answer. Plug in for a sub 1, plug in for r, but don't plug in for n. If on the test it happens to be an arithmetic situation, so this formula, let's say it's arithmetic, you're going to plug in for a sub 1, you're going to plug in for d, but you're not going to plug in for n. So plug in for everything except n. And then when it comes time to find the 30th term, now you can plug in 30 for n. Now you can plug in for n. And your calculator will basically say that it's 1.373, then you can round at that point, times 10 to the 14th power. Completely fine to just write your answer in scientific notation like your calculator is probably telling you. Number 6, find the sum of the first 60 terms of the geometric sequence. So it's this formula, which you'll have, again, you'll have a formula sheet like I've told you in class, in case you missed a whole bunch of classes. So there's the formula to use. Obviously, sum formula, geometric, but bam. And it looks like you just have to plug in for a sub 1 properly, which is going to be 0.25, the first term. R is, what's R? What are we always multiplying by? It looks like, especially when you look at these terms, it's easy to see that it's going to be a 2. And N is going to be 60, because we're adding up the first 60 terms. And there's another R, so bam, there it is. And especially since this is going to be a gigantic number, you might want to just throw all of that into your calculator at one time. And if you have an N over D button, like on the current yellow ones we have, it makes it even that much easier. So hit the N over D button first, then throw all this in here with the parentheses and everything, and the 1 minus 2 underneath, and it should tell you that rounded probably to the 3 decimal places, that is our answer. And the only thing it's occurring to me right now that I should probably mention is if R is actually a negative number, like let's say it would have been -2, then just make sure you put this -2 in its own set of parentheses. Like it would have been 1 minus, and then a -2 in parentheses that was getting raised to the 60th power. Not that it's probably always super necessary, but it's good to be paranoid, right? And it might even be necessary sometimes, or else the calculator would not give you the correct answer. So, anywho, just a matter of doing a formula, right? Speaking of formulas, sum of the first man, I'm being so nice here. Literally telling you that it's arithmetic. And we're only going from 1 to 25, but that seems bad enough. You probably want to use a formula here. So, obviously, considering the key words of sum and, sigma, on top of that, and that it's arithmetic, it should be obvious, though, if not immediately with a little bit of investigation, that this is arithmetic. But, here's the formula. And so what are we going to plug in for N? Well, 25, because we're adding up the first 25 terms. A sub 1 is going to be whatever you get when you plug in 1. Right? A sub 25, I cannot stress this enough. A sub N is not going to be 25. It's not going to be 25. It's going to be A sub 25. The 25th term, which you have to figure out by, in this case anyway, plugging in 25 for I. And to get A sub 1, you're going to be plugging in 1 for I. Ba-bam, ba-bam. And so we're going to plug in 5 for A sub 1. You right? And we're going to plug in 53 for A sub 25. After plugging in 1 for here, 25 for there. And so all of this, your calculator can tell you, is 725. Number 8, find the sum of the infinite geometric series. So if you're reading directions carefully, why wouldn't you? It should be pretty clear right away that this is the formula you're going to use from your formula sheet. We do need a certain R value, though. I mean, otherwise this won't even have a sum. Because, infinite and all. But it looks like my R value is obviously 1/2, which is the right kind of R value, common ratio value, that will result in a sum. So anyway, a sub 1 is obviously 2. R, like I just said, is 1/2. If there's any doubt, just do this term divided by the previous term to get what we're multiplying by, right? And now you just need to crunch this and evaluate this and simplify this, whatever you want to call it, correctly to get 4. Oh, switching gears to counting principle and permutations, combinations, probability. This particular question, and I mean, as always, you need to be trying these before listening to me go through this on the video, So you should have read these in advance, and this particular problem can only be done with the counting principle. Unless you want to list all these different outcomes by hand and count them by hand, no thanks. Because, and this is the counting principle because you are going to choose a color of ink, which can happen 4 different ways. 1, 2, 3, 4. And then you're going to choose a type of writing tip. 1, 2, 3, 4, 5. So that can happen 5 ways. And so it would be 4 times 5. The combination formula does not apply here at all, nor does the permutation formula. That doesn't apply here at all. This is only a counting principle situation. You're making 2 separate decisions that each can be made numerous ways. And so you multiply them together to, of course, get 20. Number 10. A club with 15 members, pretty exclusive. 15-member club is to choose 4 officers. President, vice president, secretary, treasurer. Classic question. In how many ways can these offices be filled? In other words, how many ways can we make a group of 4 from a group of 15? So that means like one of the formulas applies. But here it looks like the arrangement, the order, is going to matter, because it's like we're putting them in positions, right? So essentially, in other words, you could mix up, you could like double dip and stuff on the same 4 members, but just call them different, like give them different offices. And if that's the situation, then order matters and it's a permutation. If you can repeat the same 4 members in the same group, just put them in a different order. And so this is going to be 15P4, 15 position 4, which your calculator will tell you is 32,760. And on a side note, this also could have been done with the counting principle. You could have done this by doing 15 times 14 times 13 times 12. And that would also have told you that number. Because I'm pretty sure that if it's a permutation formula situation, it also means you can do it by counting principle. Number 11, how many different ways can a director select 4 actors from a group of 20 to attend a workshop on performing in rock musicals? Wow, that was a very detailed situation. Anyway, so this is like saying from a group of 20, from one group of 20, how many ways can I make a group of 4? So it's one of the formulas, right? But is it a combination or a permutation? Does order matter? Right? I mean, could we could we put the same actors together, the same 4 actors, in a group together more than once, just by rearranging them around? And the answer is no. Order does not matter. And so it's 20, choose 4. And your calculator will tell you that it's that. And on a side note, if it's a combination, you could not have done this with the counting principle. You only can do this with the combination formula. Unless you want to list them out by hand the long way, but just the combination formula in a problem like number 11, okay? And number 12, in how many ways can 5 aeroplanes line up for departure on the runway? Well, let's see I gave both ways. You can do counting principle, 5 times 4 times 3 times 2 times 1, which is 5 factorial. Or you can think of it as a permutation question. You got like a group of 5 airplanes and you want to figure out how many groups of 5 can you make from the 5 where order matters. Either way, the answer is going to come out to be 120. Number 13, if you draw a random card from a standard 52 card deck, what is the probability of getting a heart? Well, if you need a little lifeline during the test, I don't expect you to definitely know how many hearts are in a deck of cards. If you need to ask me during the test, that is fine. But there are 13 hearts total, so you have a 13 out of 52 chance. There's 13 favorable outcomes out of 52 total, which reduces to 1/4. If you have your answer as 0.25, I suppose that's fine. If you have it as a 25%, like a percent answer, I guess that's fine. Number 14, if you guess at, who would even do this? If you guess at every question on a true or false quiz, which contains 5 questions, what is the probability that you get them all correct? Okay, this is, in my mind anyway, a series of multiple events in a row. You guess at the first question, and there's a certain probability there of getting it right. Then you guess at the second question, and there's a certain probability there. And then there's a certain probability you're getting the third question correct, and the fourth question, and the fifth question, all separately, but this is compound probability because you're trying to do multiple things in a row that all have their own probability. And in order to get your final answer, you're going to multiply all of those separate fractions together. And in this case, it's always 1/2. It's going to be, you have a 1 out of 2 chance of getting the first question right, and then a 1 out of 2 chance of getting the second question right, and the third, and the fourth, and the fifth. So it's just going to be 1/2 times 1/2 times 1/2 times 1/2 times 1/2 to get that. Or something equivalent. Number 15. Trying to help you out here. I could have just said this was 8, and this was 11, and this was 16, and this was 20, you know what I mean? But you notice as we go from term to term to term, what's always increasing by 1 is the entire numerator, so that's going to be represented by just I, and this part in the denominator is always increasing by 1, so it's always going to be something squared plus 7 down here, and so that goes here, and we're obviously going from 1 to 12. 1 to 12. That's really all I can say about this one. You have to understand sigma notation, forwards and backwards and stuff. Ooh, a bonus question. Bonus question. Mathematical induction. Step 1 is the base case, so on the left side, the first case would only be the 3. And on the right side, essentially we're plugging in 1 for n, which does mean the left side is just 3. On the right side, we're plugging in 1 for n. And when you double check this, 3 does equal 3, so hey, that checks out. Step number 2, we're essentially assuming that the case of n equaling k is true. So you just got to write that out. Just got to write it out, man. And now in step number 3, we're going to show that the case of n equals k plus 1. So over here it's going to be 3 times k plus 1, and then in here a k plus 1 plus 1. And we're going to show that this holds true as long as this is true. So if this is true, we're going to show that all of this is true. By noticing that over here on the left side, just from here to here, we just got done, look, right here, 3 plus 6 plus 9 all the way to 3k is equal to this. So you can replace all these terms, except for this guy, with 3k times k plus 1 over 2. Because we just got done assuming it was true. So we can sub all this in. And from here on out, whoa, what happened here, man? What happened? What the heck? Well, I guess I'll fix this in a second. I don't know what happened. But essentially, once you apply your step 2 assumption, from there on out, it's just a matter of using algebra to show that these are blatantly equal to each other, left side and right side. So like over here, you see how I distributed and then distributed some more with FOIL and stuff. But over here, we had to like give, let's see here, a little bit of purple. We had to like multiply top and bottom by 2 to make common denominators. So this should be a 2, and essentially, nope, I did not. So hey, let me just kind of try to be as clear as possible about how all these steps are proceeding. So again here, well, first of all, right, k plus 1 is k plus 2. All right, this becomes k plus 2. And then I think what I did was, sorry if I said that I distributed the 3, because that's not what's happening. Once I make this just a k plus 2, it looks like I foiled these two bubbles together to get this, okay? And of course, as this proceeds, because this is not done, this right here up top is going to become k squared plus 3k plus 2. And then we're going to like distribute the 3 to ultimately get, here we go, I'm doing this in my head, which is not what I should be doing, but 3k squared plus, okay, the 3k becomes a 9k. 3k squared plus 9k plus 6, which is what you're going to get over here when you actually add these fractions together all over 2. 3k squared plus 9k plus 6, because I distributed up here, so where did this 3k squared plus 3k come from? Why, distributing the 3k, of course. And where did this 6k plus 6 all over 2 come from? Well, I had to multiply top and bottom here by 2 to give these two things common denominators. So it looks like, again, your final line of work is going to say 3k squared plus 9k plus 6 all over 2 equals exactly the same thing on the right side, 3k squared plus 9k plus 6 all over 2. And that's one bonus opportunity. This whole question you can leave blank if you're chicken. The whole thing's bonus. Another completely bonus question, you lucky ducks. Find the following sum. Holy crap, from 1 to 99. Woo! I suppose theoretically you could write out all 99 terms if you're a lunatic. So here's what you're going to do. You should, anyway, I'll get to that in a second. Sorry, I almost got ahead of myself. The first thing you're going to do is break up all of these into separate sigmas, and you're going to bring the coefficients out in front, right, like here, okay, so that you'll have sigma I cubed, sigma I squared, times this, sigma I times this, and sigma that, and then you're going to utilize the formulas I will provide. There's going to be, these formulas are going to be on the formula sheet as well. And sigma I cubed is that formula. Sigma I squared is that formula. Sigma I is that formula. And sigma times a constant, I guess specifically sigma 3 is 3 times n. Now, all of these n's, you're going to plug in 99, because that's what n is equal to in this situation. So n equals 99, and I mean, that's what you're going to do. You're now going to plug in 99 for n. Don't forget to multiply this entire beast by, 5 or negative 5, and this whole thing by 2. But here's a little bit of breakdown. I mean, are these all 4 terms? Okay, all right, okay. So apparently, I'm not going to guarantee this is true, but it looks like all of this ends up being that giant number. All of this, including the times 5, ends up being that. All of this, including the times 2, ends up being 9,900. And 3 times 99 is 297. And so all of this finally simplified is, oh my goodness, 22,870,947. And by the way, you need to show all this work to get bonus points. Woo! Okay. So that is everything you need to know, including for bonus opportunities on the Unit 5 test. Happy studying.